Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the semaphores on operating systems. Semaphores, the most robust alternative to simple mutex is to use the semaphores, which are integer variables for which only the two, that is atomic operations, are defined, the weight and the signal operations. Note that not only must the variable changing the steps like s minus minus and that s plus plus, that is decremental and incremental, be indivisible. It also are necessary that for the weight operation, when the test proves false, that there be no interruption before the s gets decremented. However, for the busy loop to be interrupted when the test is true, which prevents the system from hanging forever. Next one, weight. Weight the semaphores, then while s greater than or equal to 0, then that is no operations. Then x minus minus, that is semaphores decremented. Then followed by the signal operation. Here we have the signal s, that is semaphores. Then semaphore s plus plus, that is semaphores incremental. Next one is semaphores usage. In practice, semaphores can take on one of two forms. That is, binary semaphores can take on one of the two values, that is 0 or 1. They can be used to solve the critical section problems as described above, and can be used as mutexes on the systems that do not provide a separate mutex mechanisms. The use of mutexes for this purpose is shown in this figure, that is do open bracket weighting, that is mutex, that is here weighting is the critical section, and then signal operation mutex, and here signal operation is the remainder sections, and then while condition comes true. Next one, semaphores can also be used to synchronize the certain operations between the processes. For example, suppose it is important that process P1 execute the statement S1 before the process P2 execute the statement S2. First, we create a semaphore named synchronize, that is the two processes, and initialize it to be 0. Next one, then in the process P1 we insert the code, that is S1 signal operation, that is synchronization, and in process P2 we insert the code wait operation, that is wait synchronization S2. Because of the synchronization was initialized to 0, process P2 will block on the wait until after the process 1 execute the call operations to the signal. Next one, semaphore implementations. The big problem with the semaphores are described above is the busy loop in the wait call, which consumes the CPU cycle without doing any useful work. Next one is, this type of lock is known as the spin lock because the lock just sits there and spins while it waits. Third one is, while this is generally a good thing, it does have the advantage of not invoking the contact switches, and so it is sometimes used in the multi-processing systems. And then fourth point is, when the waiting time is expected to be short, that one thread spins on one processor while another completes the critical sections on that other processor. Next one, we have the new definition of a semaphores, and the corresponding wait and signal operations are shown as follow. That is semaphore structures. We have type structure, initial value, followed by the structure process, and then semaphore. Followed by this we have the wait operations, wait semaphores, That is, here we have that decremental. If s greater less than or equal value 0, then add the process to the s list and then block. Followed by this, we have the signal operations, signal semaphores. Here we have the incremental structures. Thank you.